Assalamu alaikum. In this lecture we will discuss the multiplication of matrices, and to understand the multiplication of matrices we should first understand that which matrices we can multiply and which are the matrices which we cannot multiply. Suppose we have different examples over here which I have already written over here. Suppose this is a matrix and I want to judge that can I multiply these two matrices or not. First of all, I'll calculate the values, the number of columns in the first matrix and number of rows in the second matrix, and then I'll say that whether these are equal or not. This is the column of the first matrix and the rows of the second matrix. If we see here, the column are 2, and if we see here, the number of rows are 2. So the number of column in the first matrix are equal to the number of rows in the second matrix, so we can perform the multiplication in these matrices. On the other hand, in the second example, if we see here we have number of columns, this is 1, and here we have 2 rows, so the number of columns in the first matrix it is not equal to the number of rows in the second column, the second matrix, so we cannot multiply these two matrices. And suppose in the third example we have different matrices, and here we have number of columns, this is 1, and again number of row is 2, which is not equal to the number of column in the first matrix, so we cannot perform multiplication in this case also. In the last case, if you see here the number of columns, these are 2, and here number of rows, these are also 2, so we can perform multiplication in these cases. Now we know how we can judge that whether these matrices are conformable for addition or not, multiplication or not. And here we will learn, here we will learn how to multiply these matrices. Suppose this is first row, and we will multiply this first row with first column, and then second column, and so on. And whenever we are multiplying a row with a column, look, we have two elements over here, 1 and 2, and we also have here two elements, that is 0 and 4. The first element will be multiplied with the first element, and the second element will be multiplied with the second element, and their answer will be written in one row and one column. I mean that will be solved at one place. Now suppose we want to multiply this row with that column. It's wise to have hide other rows while performing multiplication. We have 1 zeros are, that is 0. Then we will multiply the signs, that will be 2 fours are 8, and positive into positive, that's positive, so that will be 0 plus 8. Now we have multiplied first row with first column. Now we will say do the same with first row and second column, and we will hide these values, and it will be 1 2s are 2, then plus into plus, and then 2 1s are 2, so it will be written over here. We are multiplying second row with second column, so the answer will be written in first row with the second column. The answer will be written in first row and second column. Now we are multiplying second row with the first, so the first number will be multiplied with first, so 3 zeros are 0, and then positive into positive, and then 4 fours are 16. Now we will again multiply second row with second column, and the answer will be 3 2s are 6 plus 4 1s are 4. Now we'll just add them and we'll get the answer. This is 8, 4, 16 and 10. Okay, now let's consider another example to understand it more clearly. Suppose I have another matrix. Suppose I'm multiplying 1 2 with 3 4. First I will just check that these matrices are conformable for multiplication or not. Here we have one column and here we have one row, so there's no problem, we can multiply these matrices. First we will multiply first row with first column. In first row we have only one element, so it would be 1 3s are 3, so we'll just write answer over here. Then first row second column, and we will also move first row and second column, so the answer will be written over here. So 1 into 4 will be 4. And now if we see, we will just multiply, we will hide this value and we will multiply second row with first column. That will be 2 3s are 6, and we have no other elements, so just leave it over there. And now we will multiply second row with the second column, and the answer will be 8, and we will get this matrix. Now if you want to judge that what order does our answer will have, we can just guess that. Suppose the order of this matrix is actually 2 rows and 1 column, so it is 2 cross 1, and in this matrix we have 1 row and 2 columns, it will be 1 cross 2. And now if we see, if we eliminate the column of the first and the row of the second, we'll get the order of the resultant matrix, that is the product of the matrix. It will be 2 cross 2, and here we have a 2 cross 2 matrix. Okay, let's solve another example. Suppose we have a matrix A, and matrix A is 2 1 5 3, and a matrix B, and B is actually -1 2 -1 0, and I want to find the product AB. And to find out the product AB, I'll just use the values of the matrix. 2 1 5 3 multiplied with -1 2 -1 0. Now again, I have already told you that we will just multiply first row with first column, then first row with second column, and so on. And similarly, second row with first, then second row with second column. So when we multiply first row with first column, we will get -2, then plus into minus, and this will be -1, and then first row into second column, it will be 2 2s are 4, and then plus 0. And similarly we will multiply second row with first column, so the first element will be multiplied with first, and the second element will be multiplied with the second, so this will be -5, then plus minus, 3 1s are 3. Now the last step, we will multiply second row with second column, and we will get 5 2s are 10, and positive 3 0s are 0. So now our answer will be -3 4 -8 10. So this is it. This is the product of matrices, and this is very helpful in further applications.